Hello everyone, we're the Energy Harvested IoT wireless device team, and we're going to explain our setup. So here's the PMIC. It's currently fried right now, so we're not going to have the full device operating at this point. But as you can see, we have our battery, our LiPo battery, connected here. And then this BAL pin, you can either use a capacitor with it, but right now we just have it to ground, which is kind of the default. Then these two pins you can also leave floating. They basically just configure the output load as well as like the sampling rate for the solar cell. Then these pins configure the PMIC to be getting to set the voltage thresholds for the LiPo battery. And then these are control pins. Really the only one we care about is the enable sleep pin, which just always has to be low. And then we have these load configure pins, which sets the load to be around 3.3 volts. And then finally these digital outputs is what can be read from the microcontroller to determine if a certain threshold has been reached. And then these are the load pins, and this is where you connect the solar cell. And then on this side, so we have our sensors, and this is our microcontroller, and if our device was actually operating, our load would go directly into this VIN pin right here,
which is currently connected to a power supply.
And then our solar cell would be connected up here. So now Devin's going to talk about kind of what we have going right now.
Yeah, so right now, since our board is fried, we had to test with the bench top power supply. And so that's currently running into a current and power, reader. It's able to determine the current being drawn by the board, the power generated, or the power consumed, and the voltage used, and that's I²C, which is also on a line with two sensors, a lumen sensor for light, and then a humidity and temperature sensor. Those are all on the same I²C line, which connects just to the Nordic board. And then the board is also connected to the solar cell, which ideally would be connected to the source on the PMIC, but we don't have it right now. Right now, the solar cell is connected through a resistor ladder, voltage divider, to read the analog voltage generated by the solar cell into the board, and we're able to determine how much power is being how much voltage is being generated by the solar cell. And this is all connected over BLE to a computer.
And prior, we did have this current.
Prior, we had the current sensor connected to the solar cell as well to determine the
power output
of the solar cell.
And so now on the GUI side, our website side,
we have a web app basically explaining all the measurements that we took from the system over there. So you can see we have a lux sensor, or lux measurement for our lux sensor, temperature and humidity as well, the panel voltage, and then the rail current. And you can see their visual representations here. We currently have the sample interval to 5 seconds, but you can change that, and then the next cycle it'll change. And then you see we have the PMIC status for when that was actually working to tell us our battery voltages and whatnot.
And then you can also export, here, go down. You could export all the sensor data to a CSV file.
And then just to prove this is connected, so Devin, if you want to put your hand over the sensor.
I'll go ahead and shine a light on the solar cell, first off, show the current value.
Current value is 304.
Well, this is not connected to the solar cell, so show the.
It's connected to the solar cell. So right now it's 3.76.
Okay, you're talking about the voltage. Yeah.
Voltage reading,
okay.
And then if you shine a light.
It's gonna take a minute since the last second.
Oh, well, we're gonna be waiting a minute, so. Here, maybe
Oh, that's gonna be
we
fun.
can talk about
Talk
the
about
graphs for now.
Yeah,
That's
so
where-
so the graphs. So currently, as you can see that it's basically our energy consumed is a lot higher than our energy generated. But this is of course without optimizing certain things in our code. I estimated that the energy consumed would be basically like at least 10 times lower than this if we can actually operate in sleep mode. So that's a potential future application or future work.
And then we can check the
Yeah, let's check.
measurements again. So
It's currently 3.74. If you shine a light, it jumps up to
4.22.
4.22. If you cover it with your hand, it drops down to 1.26.
So yeah.
Yeah.
So that's our video. Thank you for your time.